Muito bem, então, boa tarde, pessoal. Agradecer aí a presença do pessoal que está nos assistindo e agradecer também a presença e disponibilidade do meu colega e amigo Will McClintock. Is that okay?
Fine.
More or less?
Yeah.
Ele é da Universidade da Califórnia, né, e membro do Centro de Ciências Marinhas, e vai nos apresentar hoje um pouco da plataforma SeaSketch, que é basicamente uma plataforma focada no planejamento espacial marinho, principalmente para a definição de áreas de conservação. Will, they are all yours, anytime you want.
All right, I'll start my presentation. 1 second, I have to give permissions to the app. My apologies, I'm back. Okay, so thanks for everybody for coming. My name is Will McClintock. I'm a senior fellow at the National Center for Ecological Analysis and Synthesis, which is a group at the University of California in Santa Barbara. And I've been there for the last couple of years. Before that, I was a researcher at UCSB's Marine Science Institute. And before that, doing a postdoc and learning something about marine science, because I actually don't have a formal education in marine science. My background is in evolutionary biology and behavioral ecology. It was only when I was a postdoc that I was exposed to the world of marine science and, in that context, marine spatial planning. So I'll begin with a little bit of a background for those of you who don't have it in marine spatial planning and marine planning in general, and then begin talking about SeaSketch, which is an application that is developed in my lab at the university. So this is a little bit of an idea of how the ocean space looks near where I am in Southern California. This is the Santa Barbara Channel, which hopefully you can tell from this cluttered map is a very busy ocean space. We've got lots of recreational activities like kayaking and surfing and commercial and recreational fishing, oil exploration and production. We've got aquaculture, shipping, major shipping lane that goes through the channel. And then we have these wonderful marine ecosystems, very unique ecosystems around the Channel Islands. Sometimes that's called the Galapagos of North America. It's a wonderful place. So it's this beautiful ocean space with vulnerable ecosystems has lots of human activity, and oftentimes those activities are in conflict with each other spatially. And this isn't just a thing here. It's kind of a global problem. This is a map that was created back in 2008 by Ben Halpern and his colleagues, and it's been updated a few times since then. But it shows the distribution of the cumulative impacts of human activities on ocean ecosystems globally. And one thing you can take away from this picture is that human activities actually impact pretty much every place in the ocean to some extent, more in some places than others, but there are these impacts that happen globally. So marine spatial planning is an attempt to resolve the conflicts between these human activities and decrease the impacts of these activities on vulnerable ecosystems. So marine spatial planning brings together the science to then inform how ocean space can be used sustainably and protect those ocean resources. And the science often occurs in the form of maps that describe the distribution of human activities and habitats and so on that stakeholders can then use to develop plans for ocean zones that achieve those various goals of sustainable uses and protection. So back in 1999, this is when I just started my postdoc, a law was passed in California called the Marine Life Protection Act. And that law required the establishment of one type of zone. Well, marine protected areas with a couple of different flavors. No-take areas, protected areas that disallowed all kinds of extractive activities. And then other kinds of marine, they call them marine conservation areas, places where activities were more or less limited. So mainly different kinds of fishing activities were disallowed or allowed. And at the beginning of that process, or the beginning of right after the law was passed, a group of very smart scientists that were associated with a California agency and some academics came together and identified areas up and down the California coast, which is quite big. I think it's about 850 miles long. They identified the places where they thought these marine protected areas should go, the conservation areas and the reserves and so on. And they used the best readily available science to do that, and then came to the public with those plans to get their feedback. And universally, they got negative feedback. It didn't really matter who the stakeholders were. If the fishermen, objected to them, often the complaint was these protected areas, these zones that limited their fishing activities, prevented them from fishing in some of the most important places to them as fishers. So, you'd hear the common refrain, if you put that marine protected area there, I'll go out of business. So they were unhappy with the plans. Conservationists, even though this was a conservation law, an attempt to create marine protected areas that protected California ecosystems, they were unhappy because they felt as though too few of the important ecosystems were being protected. So despite the fact that these were well thought out plans, zones within California state waters, nobody liked them. So after a couple of rounds of trying to create these plans and get acceptance from the public, a group decided to create the thing called the California Marine Life Protection Act Initiative, which was a process that kind of turned things on its head in the sense that stakeholders were required to draw these marine protected areas that met very strict science and policy guidelines for ecosystem protection and minimizing impacts to fishers. So whereas in the beginning, before the initiative, the scientists and the agency folks were responsible for drawing the maps, in the initiative, only the stakeholders and members of the public could draw the maps, but they had to do it in a kind of order. And that order began with these regional stakeholder groups. So California was divided up into 4 regions. We ignored San Francisco Bay, but the South, Central, North, Central, and North Coasts, each of them had their own stakeholder group. And those groups were between 30 and 60 people who represented various constituents. So commercial and recreational fishers, conservationists, teachers, scientists, oil, the ports, the military, all of these had representatives in these stakeholder groups, and they would meet for 2 days straight. So socializing in the evening, getting to know each other, but 2 days of really jam-packed work. Then a month later, they'd come back together, and a month later, they'd come back together. So each of these groups met about 9 times. And they were educated about marine protected areas and MPA science, and they learned how to use various decision support tools and interpret them. But they were the ones who then drew these lines on the maps, and they had to keep in mind these design criteria that were developed by a science advisory team. And first of all, these zones that they were drawing had to fall along straight lines, so east-west, north-south, because that would help with knowing whether you were inside or outside of a particular zone, right? So if you're a fisher inside, you really want to know that you're, not supposed to fish there, for example. Or if you're an enforcement officer and you're trying to determine whether someone is fishing illegally, it's easier to have a zone that's defined by straight lines than if you have some strange shape that follows, for example, a bathymetric contour. In each of these zones, they had to have adequate representation of all the key habitats. So at various depths, for example, hard and soft bottom, those habitats had to be replicated within a threshold distance. So, for example, you had to have 2 MPAs with the same habitats represented with no more than, say, 60 kilometers apart to accommodate for dispersal of organisms. Habitats, the MPAs should achieve a maximum level of protection wherever possible. So that maximum would be a marine reserve where there's no take. But if that wasn't possible, then maybe allow some sort of fishing activity that didn't disturb bottom habitats. And then in all cases, they had to minimize socioeconomic impact to the commercial and recreational fishers and other uses. So you can tell by these design criteria that this is really a conservation objective, with the side note of minimizing socioeconomic impacts, the negative impacts to commercial and recreational fishers. It's possible that these marine protected areas created some level of fishing opportunity by protecting habitats that allowed organisms to grow bigger and then spill over into neighboring areas where they could fish. There's some evidence that that's true with some kinds of commercially fished species, and lots of cases where that evidence has not yet been established. But in any case, this is really a conservation law and a process for creating marine protected areas with the objective of conserving these key habitats. So this was a very, I think, widely accepted as a very successful process. It worked. They created a network of marine protected areas, and there are a couple reasons why it was so successful. One is because it was very well funded and very well run. I think the total cost of this design process was $30 million. It took 6 years. There was tons of public engagement, lots of science, new science that came out of it. And another thing I think that really lent to its success was this application that we developed for the stakeholders to use in the drawing and analysis and sharing of their plans with other stakeholders. And that's what's showing on the right there, this thing called the Marine Map Decision Support Tool. This was a web-based application so that stakeholders could use to visualize all the various kinds of geospatial data that were available at the time. So distribution of habitats, distribution of human activities like fishing. Then they could use very simple drawing tools to sketch out a plan, evaluate it based on those criteria, and then share it with other users who can then copy it, modify it, and share it back and forth. So a very successful process and a very effective tool that was used by stakeholders to draw over 30,000 designs that were eventually whittled down in the process to 126, I think, new marine protected areas that represent over 16% of California's state waters. So that's 0 to 3 nautical miles up and down the coast. And half of those were no-take zones. So successful in the context of a conservation process, a conservation win, if you will. And because of the success of the process and success of the tool, we got a lot of attention. There were a lot of papers written about it. And so that led me to my next endeavor. But before I get into that, I just want to point out that the expert designs, those MPAs that were drawn by state agency personnel and academics, were not a whole lot different from the ones that were eventually drawn by stakeholders. in that process of 6 years and $30 million, they came up with plans that were quite similar. So why did these plans that were drawn by stakeholders succeed? What was the magic sauce that allowed these to get signed into law where the other ones were rejected? The answer to that is quite complicated. In fact, there's this really great book that came out this year called Beyond Polarization that I highly recommend you read. And if you're interested, you can contact me and I'll send you a copy. This book details the whole California Marine Life Protection Act initiative in terms of the law and the science and the process and marine map and everything that went into it. To me, it's fascinating. It's a page turner and does a really great job of describing the complexity of the whole process. But in terms of my involvement, I knew that part of the success really of the process and the establishment of these marine reserves came from this marine map, that this tool that helped users understand geography, understand the science criteria, help them communicate with other users, other stakeholders using this common language, which included geospatial data and analytical tools. It really explicitly helped users identify their shared and diverging interests in terms of where these marine protected areas would go and why. And in the end, facilitated a joint problem solving, a collaborative effort to solve this problem of where marine protected areas should go. Another paper that I'm happy to send you if you're interested. And if you kind of really look carefully at marine map and dive into what it is and what it does, it's quite simple. It's a Geo Design application. And if that's the term that's not familiar to you, Geo Design is simply iterative sketching and analysis. So sketching an MPA, sketching a marine protected area, for example, analyzing it, editing that MPA to change the boundaries a bit and analyzing it again. And in sort of a hunt and peck way, like looking at what this looks like and how this other one looks like, back and forth. By doing this iterative sketching and analysis, you come to understand the potential benefits and impacts of your design, which can ultimately lead to action, the establishment of protected areas that achieve conservation objectives, for example. So geodesign made sense to me, and I was thinking at that time, so it's back in 2010, about 10 years ago, that where else can this methodology be applied? And this was right around the time that marine spatial planning was really starting to become a household name amongst lots of different governments. And it's different than, say, marine protected area planning in the sense that it's an attempt to comprehensively look at all human activities, balance their uses in a sustainable fashion, and protect ecosystems at the same time. So not just marine protected areas, but aquaculture zones and shipping lanes and mooring and anchorage zones and tourism zones, energy zones, all of these kinds of zones that are an attempt to kind of minimize conflict and balance the uses. So I was fortunate enough to get a gift from Jack Dangerman and Esri, which I think many of you might know. It's a company that builds geographic information system software, GIS. I think it's the most commonly used GIS platform in the world, ArcGIS or ArcMap. This was right around the time that Esri was launching an oceans initiative. So they gave me funding to develop kind of the next version of Marine Map, which we called SeaSketch, which is a tool that we launched in 2012, and it's a software service. So a software service like, think of Google Docs or Google Sheets. It's a web-based application that anybody can access as long as they have a computer and an internet connection. It is a desktop application, not really mobile capable or compatible. But it has a lot of the same features as Marine Map did, with a lot more. And since launching, we've created a bunch of different SeaSketch projects all over the world, and these projects support planning initiatives that have lots of different goals and objectives, but often, they have some very common features amongst them. For example, the use of geospatial information, the desire to engage stakeholders, often as much as possible, putting them in the driver's seat, so to speak. Sometimes they're driven by fisheries or conservation or energy or tourism, but ultimately they're trying to come at this problem through a more comprehensive analysis of and then planning for all the different ocean uses. The projects, the SeaSketch projects, not just the initiative, the projects have all these common features. They use SeaSketch to contribute information. For example, where they fish and how they value those fishing places, or where they take a boat, or where they like to place a mooring. Visualize that information that they've contributed, along with authoritative maps like habitat maps that have been derived from, say, remote sensing. And then using that information together to sketch zones, evaluate their potential impacts. For example, do they meet science guidelines for ecosystem protection and minimizing impacts to fishers, so on. And then share those plans in a forum along with map bookmarks and other contextual information to advocate for a specific plan. And in that way, collaborate with other users to develop some sort of common vision for how the ocean space is managed. We've used SeaSketch in lots of different contexts, in different countries with different cultures. It's in different languages. And so sometimes stakeholders are using SeaSketch at home, using their own computer, where they're sketching plans and preparing for stakeholder meetings the next day. Oftentimes, most often, we're using it in some sort of facilitated context where we're in a meeting and somebody's displaying SeaSketch on a projector. Then people are going up to the screen and pointing things out while a facilitator sketches a plan that they're describing. Sometimes we have meetings where stakeholders are broken up into little groups and they work collaboratively, crowded around a laptop. But in all cases, they've been using SeaSketch in situations where they've been connected to the internet because it is a web-based application. So I want to demonstrate SeaSketch for you. And before I do that, let me just give you a little bit of a context for the project I'm going to show you, and I can show others if there's interest. In Montserrat, which is a small island in the Caribbean with about 4,500, 5,000 people in its population, the government there decided they wanted to do comprehensive marine spatial planning. So we created, in collaboration with the Wade Institute and stakeholders in Montserrat, we created this application, which allowed the users to identify valued ocean areas, contribute information about where they did certain things. We used that information to create these heat maps, like you can see in the lower left here, that describe the distribution of those valued activities, in this case, valued fishing areas. And then a steering committee of various representatives from sectors in Montserrat, about 20 people, used SeaSketch over time to sketch and evaluate various zoning plans. So in June, it looked something like this. And then a year later, it looked something like this. And they got a little bit of an assistance from people not just on the island. This plan down here wasn't achieving some particular goals and objectives the steering committee had required. And it just so happened that there were students in the Azores who were using SeaSketch in fact, the exact same project, the Montserrat Project, to learn about marine spatial planning and sketch and evaluate plans and learn how, collaborative geodesign can work. And in that process, a learning process, these master's students created a plan in SeaSketch and then submitted it to the steering committee in Montserrat by way of SeaSketch in the forums, which was then is currently being considered by the Minister of the Environment's cabinet in Montserrat. So I like this example because it shows that interesting ideas for how ocean space can be managed can come from remote places, not necessarily the people that you would expect to have those ideas. Collaborative geodesign through SeaSketch can happen, globally. You can have distributed groups working together to solve particular ocean management plans. Okay, so let me pull up SeaSketch so you can have a look at how this actually works. And I'll bring up the Montserrat project. So we're looking at the project that I was just talking about. And here you can see this fishing value map. This might be a little bit small on your screen, I apologize. But the red areas are high value and the blue areas are lower value. How did we come up with this map? And what was the context? Well, when we got to Montserrat, when we first started working in Montserrat, we didn't have much more than what you're looking at here. Just, an aerial image and a boundary that described the planning area, again, 0 to 3 nautical miles, and not a lot of other bits of information. And we knew that we were going to need to have a habitat map. So there was some scientific papers that showed the distribution of these various habitats, algal reefs, artificial reefs, volcanic boulders, coral reefs, and so on. Those maps were refined by doing some dive surveys through, I think, something like 300 dives around the island to verify these habitats. And then we were confronted with the problem of understanding where people were going and what they were doing within these waters. And so we conducted a survey in SeaSketch where we asked people, we sat down with people and asked them a variety of questions like this. We asked them, do you boat? You go out on a boat? Maybe no. Do you fish? Yes. Okay, well, where do you fish? And the stakeholders would either use SeaSketch themselves, like using the mouse and draw areas in the ocean, or they'd point to the screen and a facilitator would fill it out for them. But they might say something like, well, I like to fish on this side of the island, a little bit offshore, and I use hook and line. And maybe I use some pots over here occasionally. And okay, where else do you fish? Well, I fish a lot over here because this is the main city, capital, where I live. I fish up and down this whole coastline here, out to, maybe we measure it for them, or maybe we use bathymetric contours. And they indicate, well, I do some spearfishing out here, and I also use hook and line. And then they draw all the areas where they fished. And we'd ask them, all right, now that you've drawn all those areas, help us understand which ones are more valuable. And value could be anything really that they decided to call it. So it could be the amount of money that they made from selling the fish that they caught. It could be the pounds of fish that they caught, or the amount of time that they spent fishing there, or simply its spiritual value. Didn't really matter. In this particular study, we weren't interested in defining it any more than just its relative value. So once we sort of had that discussion about value, we'd ask them to place 100 points amongst these various areas that they'd drawn to indicate their relative value. So for example, if they spent 10% of their time over here on the east side of the ocean, they might give that place 10 points. And if they spent 90% of their time on the west side, they'd give this area 90 points. So SeaSketch would then validate that they've given 100 points to their areas. And if they didn't have any other information to contribute, they'd submit their response. And that became a part of this database that only administrators had access to. So this was other members of the public or people contributing information couldn't see individual responses. Only administrators like me could see the responses. So this is what, let me change this map real quick so you can get a better sense of what this looks like. This is basically the raw data from that particular survey in Montserrat, where people were indicating valuable places from one perspective or another. Those responses could then be downloaded as a shapefile, summarized offline, and then uploaded as a map service so that the public could see that image I showed you earlier, which shows the distribution of high value and low value areas from the perspective of the fishers that responded to the survey, which we think represented all of the people, most of the people that fish in Montserrat. So how is this information used? Well, these folks in Montserrat were interested in creating a variety of different types of zones, which included no-take and partial take marine protected areas, mooring and anchorage zones, a shipping lane, volcanic exclusion zones, so places where you could transit through but not stop and fish, because in case you didn't notice in the first image, there's a big volcano on the island, and sometimes these places over here and over here on the west and east side are vulnerable when the volcano erupts. So kind of an interesting zone type that you don't see in most places I work. So they would use these data to then begin sketching and evaluating prospective plans. So, for example, if someone said, well, I want a marine protected area that, goes all the way out here, and maybe I'll consider making it a no-take zone, but geez, that's a lot of valuable fishing area, so maybe I'll consider a different zone type. I'll consider marine reserves that allow fish and line, hook and line fishing, or allow gill net fishing, and then save that. Oops, got to give it a name. That concept of a no-take zone is then saved into this private sandbox, if you will, a place where I can explore various kinds of ideas and then evaluate them. So I can run some analytics that will eventually, these are a little bit slow, this is an old project. Eventually this will tell me something about the consequence of my design. Am I meeting, for example, the objective of protecting various ecosystems based on that habitat map that you saw, and other kinds of information. And there's lots of different kinds of information that one can use, and the analytics that you can run in this are sort of endless. It's just up to you to decide what's important. Sorry, these are really old, so I'm just going to show you a different analysis. Here's a plan, or here's a set of plans. Showed you a picture of this earlier. This is the set of plans that was created by the steering committee. So you can see that there are a bunch of different zone types, not just protected areas, reserves, mooring and anchorage zones, a recreation zone. That's really small. That's right here by the main town, shipping zone, port authority zone, so on. This group of zones that they drew can be evaluated just like any other zone type or individual zone, where you get some indication of how much area is covered by your plan. In this case, it's the entire study region, all of 0 to 3 nautical miles, and which of these partial take and no take marine reserves cover valued fishing areas, right? So here's the underneath, and it's maybe hard for you to see, but underneath this zoning plan is this fishing heat map that I showed you. And the analysis tells us that no take and partial take marine reserves cover 25.8% of the total fishing value within Montserrat's waters. No take covers 17, almost 18% of the total fishing value. So a fifth of the valued fishing areas in Montserrat were covered by no-take marine reserves. Is that too much for fishermen? Is that adequate? Does that serve the fishermen well over time by creating spillover effects? That's something that is hard to say unless you're a fisherman, which is why we spent a lot of time with fishermen, showing them these maps, asking them to create different kinds of maps that were more suitable to them. And we did that in evening meetings with small groups of fishers. We did these public meetings. We had the steering committee meetings. And over time, the negotiation process led the steering committee to create this map, which was then improved, as I mentioned earlier, by the students in the Azores by including this particular design. That design helped the steering committee protect more of the key habitats in the Montserrat waters. So the previous design, the ones that the steering committee came up with, fell short of the 30% protection goal for a couple of different key habitats, and even fell short of a 20% protection goal for one of the habitats. The design that the students drew actually met the 20% protection goal for all of the habitats and just fell short of two of the habitats, but not very short for two of the habitats. So it was an improved design. So what did they do with these designs once they drew them in SeaSketch? Well, then they went into the forums and submitted these designs for others to use. So let me turn these off. I'll turn off that heat map. So, for example, the steering committee held a bunch of different meetings, and like in this one, you can see that there were two people that were posting messages in the forums and saying things like, here's a map bookmark. I've drawn this particular zone. Areas within this zone that are strictly no-take. These are areas, the idea here is that they're going to draw zones that don't disallow fishing all over here. And the reason I know this isn't because of what Laverne says, but I'm looking at a bookmark of a map that Laverne drew, and that's bookmarking this layer right here. What is that layer? That layer is showing me a prioritization map, a priority map, a conservation priority map. That was developed, and I can pull up the metadata on that. That was developed by a group of scientists that using a process this described in this paper, that took those habitat maps and some conservation priorities, some objectives that the steering committee had come up with, and it created a priority area map that showed, well, if you're trying to protect all the key habitats at X%, these are the places that you want to protect them, or you want to create a marine protected area. So Laverne has bookmarked this priority conservation areas layer and posted a prospective zone. Well, this is open to the public, by the way. Actually, I'm not sure the steering committee forum is, but the public forums are. Anyway, anybody who has access to one of these forums could then say, well, I like that design, sort of, but that's pretty big. That's covering a lot of fishing area. I could run a report and it would tell me exactly how much of the fishing area it's covering. But I know as a fisherman, that's just too big. I can't live with it. But I can copy Laverne's plan to my plans tab. This is my private area, and then edit it. So I'm going to take Laverne's plan and delete some of the vertices that were created when she drew her plan. And well, maybe I'm just gonna, I'll move some. I'm gonna move this down here like this, because I know that I like to fish out here. And well, that's good enough for now. I'll save it as Will's version. And then if I want to continue the discussion with Laverne, I could copy that in the same forum and say, consider this alternative to Laverne's design. And bookmark the map, and maybe I would choose to show different layers. So instead of the conservation area, I'm going to show the distribution of valued fishing areas and the benthic habitats. So she knows what data I'm thinking about when I post my design. And then if I hit reply, this goes into that form, which I won't do because this is a real form. You can see that this is happening on June 6th of 2017 at 8 o'clock in the morning. So this is a real-time discussion that was happening with a group of stakeholders in a room. So what I like about this is that it really helps us track how plans were developed, who created them, what kind of data they were referencing, and the kinds of analyses they were using to guide their thinking and where zones should be placed. So there's this record now in SeaSketch of all the various interactions and collaborations that created the plans that are now being discussed by the government in Montserrat and potentially get signed into law. There are lots of other examples. And one of them, for example, is just this a nearby island where there are now, wow, this is the first time I've seen this. We're looking at the OpenStreetMap base map in SeaSketch that shows sanctuaries now in the ocean. Goat Point Sanctuary, the Codrington Reserve, 2-foot bay sanctuary, low sanctuary. This is interesting because I believe that's wrong. Anyway, this is a map that's created. It's an open source map. But how did those things get there? How did those reserves get there? Well, if you go into SeaSketch and you go into various forums, and I believe this one is public, you can look at a meeting that happened on October 4th of 2013. And in that meeting, you can see that I was there along with this guy named Chad Burt, who happens to be the lead developer for SeaSketch. And we were with Ayana, the executive director of the Blue Halo Initiative and the Wait Institute at the time. And we were meeting with fishermen and asking them where they would like to have marine protected areas. And you can see that here, someone was presenting this idea that this thing be turned into a Goat Point sanctuary, which it is now. And Devin Warner proposed this design. Now, I know, and I can, I know because I was there and because I've seen the laws that were passed, that this is actually the design for where a marine protected area should go in the south of Barbuda. So I'm curious to know why that's not represented in OpenStreetMap, because Devin Warner presented this, and lots of people like Colin Beezer supported that particular design. We know that because it was noted here in SeaSketch on October 3rd, 2013. So I really like this. It's a great example of how we now have, we can really demonstrate how stakeholders put their fingerprints on these designs that were eventually signed into law, and when and why and what data they were looking at, what maps were guiding their thinking. Okay, one last comment. So if you want to see any of these projects, you can just go to seasketch.org and hit the projects button at the top. That will show you a map that shows the distribution of all these different projects. And you can search for things like Barbuda and click on the icon that comes up and choose visit the project, and you can see that project's still alive. And you can walk through all the data that are still there and visible, and all the plans that were created by stakeholders. Okay, so let me go back to showing you my PowerPoint. Just a few more slides. You are welcome to read up on either of those processes, the one in Montserrat and the one in Barbuda, by taking a look at these papers that came out this year and last year. If you want these, I can send them to you as well. No, I'll provide my email at the end of the talk. Now, last year, in October of 2019, there was this thing launched called the Blue Prosperity Coalition, which is a group of lots of different organizations that have pledged $150 million to do comprehensive marine spatial planning globally with an eye toward the blue economy and conservation. And I received a grant to support that initiative for the next 5 years, hopefully for another 5 years after that. And as a big part of that initiative, we are redeveloping SeaSketch from the ground up. So what I didn't mention is that SeaSketch requires currently a $1,000 a year license fee, which an organization can purchase and then have unlimited use for any number of stakeholders to use it. But then the analytics, the reports that are in SeaSketch, the ones that told you, for example, overlap with habitats or overlap with valued fishing areas, that kind of information or those kinds of analytics generate reports that are then displayed in SeaSketch. We have to write those analytics because of the way that the application was written and some of the dependencies we have on proprietary technologies. My lab had to write those analytics, and that created a bit of a bottleneck and challenges for lots of places we're trying to work, which don't have funding to a $1,000 license fee, much less, let's say, $25,000 a year for writing those analytics. That's just a lot of money. So we are writing SeaSketch from the ground up as a completely free and open source tool. And there's a lot that goes into this. It takes 2 years to redevelop SeaSketch. We're halfway through that. We're going to launch the next version in the beginning of 2022, so in just about 13 months. And one of the most exciting things to me is this open geoprocessing framework. So this is something that if you're a developer, you can take advantage of by writing your own code and then posting that analytical code on what's called AWS Lambda, a serverless architecture that allows you to very cheaply and quickly run these kinds of analyses. And in fact, just about any kind of analysis you can think of. I didn't show you, but there's projects that we have where we're assessing the cumulative impacts of various kinds of, or the changes in cumulative impacts of various kinds of ocean zoning plans. Those cumulative impact analyses we can do in SeaSketch as it is right now, but it's very slow and very complicated. And but with a new geoprocessing framework, it'll be more efficient. We'll be able to do multi-threaded sorts of analyses, and that can happen in seconds. So those sorts of complex analyses, other kinds of modeling, or incorporating other decision support tools like MarkSand, running MarkSand within SeaSketch, for example, all of that will be made possible through this open geoprocessing framework. So all of our code, as we're developing it and publishing it, is appearing on GitHub and can be used. But the really useful stuff that will be coming out to other projects will be this open geoprocessing framework. And it could be used for anything spatial. It doesn't have to be marine spatial planning. It could be land-based planning. It could be just be collaborative research between scientists who want to share various kinds of geospatial information and so on. So I'm very excited about the potential for this, and very grateful to the Waite Foundation for funding the development and implementation of this tool over the next 5 years. So it will be, open source license, no license fee, and the API for geoprocessing will be open, so anybody can do that if they have programming skills. So it's not going to be simple. It will require probably knowledge of JavaScript, for example, but open and free nonetheless. And besides the fact that it's going to be open source, it will have lots of different improvements. For example, we'll finally integrate mobile technologies. Right now, you can sort of use SeaSketch on an iPad, for example, but it's not really designed for that. The next version will be, and it'll run on a phone as well, which will be particularly useful for when we're doing those spatial surveys and asking people to identify their valued fishing grounds, for example. And the tool will be much more interactive. We'll be using the Mapbox mapping interface so that drawing will be more intuitive. And the display of geospatial information will be much more flexible. So I didn't go into the details, but currently, when you pull in maps into SeaSketch to display them to users, they are map services, and the cartography, the way it looks, the colors and so on, the icons, those are predetermined by the cartographer that published the map service. So if you're not the owner of those data, if you're pulling them in from, let's say, some service in Europe from the European Union, you are really stuck with using their cartography. But not with SeaSketch Next. The way that it's being developed now, you'll be able to pull in maps from GeoServer, an open source web mapping service. You'll pull in data from ArcGIS Server or from Mapbox, and using those services, in a lot of cases, in most cases, you'll be able to apply your own kind of symbology and stylize it the way you want, so that the combination of those data with your own data and data coming from other services, other service providers, they look right and they work well together, sort of intuitively, to help local stakeholders do their planning. Okay, so there's more that I can show you, and I'm happy to take questions, but these are the kinds of messages I wanted to convey. First, I think ocean zoning is a good way to balance ocean uses and protect ocean ecosystems. You probably noticed that a lot of the examples that I showed were very conservation heavy. That tends to be a big driving force in a lot of the marine spatial planning initiatives that I've seen. But it can be much more comprehensive to involve not just MPAs, but aquaculture zones and fishing priority zones, for example. But it does, it can be conflated in some ways with conservation planning. But it really works best when stakeholders are heavily involved in the zoning process, and the more they're involved, the better. If they actually have hands-on experience with SeaSketch, they'll understand the process better. They'll understand the science better, the goals and objectives, all of that, and ultimately, of course, they'll feel a greater sense of ownership. Remember the example of MPA planning in California. If the scientists drew the plans and presented them, in good faith to all the stakeholders, simply because the stakeholders didn't draw them, they were rejected. But if they were drawn by the stakeholders using science guidelines, they had a chance of success and they were actually signed into law. So maximizing stakeholder involvement is key. Volunteer geographic information is one way to assess how people value ocean space. So I didn't use that term, but when we were soliciting stakeholders' input on where they valued, fishing grounds or boating areas or whatever places they use the ocean for, that process is referred to as volunteer geographic information. And that I have yet to work anywhere in the world, and I've probably worked in 25 countries. I haven't worked anywhere where volunteer geographic information hasn't been essential to planning, because there's a lot of information that is in people's heads but can't be collected necessarily, or hasn't been collected by way of remote sensing. So VGI, volunteer geographic information, still remains one of the best ways to get people's information, particularly how they value ocean space. Collaborative Geo Design, that process of sketching and evaluation, is a really good way to present and explore management scenarios. There are lots and lots of ways to improve that with prioritization tools and trade-off analyses and cumulative impact analyses. But geodesign works really well with those other kinds of approaches and tools to help people express their ideas and evaluate them based on some sort of standard metrics. And then finally, I'm really excited about this free and open source version of SeaSketch. Like I said, it's going to be out in about a year, 14 months or so. And I'm very optimistic about how that will really take off and allow people to have better access to planning tools that can support their various zoning initiatives. So that is it, and I very much thank you for your attention.
Thank you, Will, for your willingness to be, today with us. I don't really know who we are actually, who are, for the people who is actually watching us. But now I will wait for the questions. Some questions that I got from my group here were about costs. So I guess your SeaSketch next killed most of them. But let's see what else people want to know.
Yeah.
Meanwhile, I was just want to make one single question, because something that, sorry about the noise, because I got a truck here. Yeah, the garbage. Something that makes me really happy to see in an application like this is that it's based on the data that are already available and on perception. We have this thing in Brazil here that it's sort of a cultural thing. Mostly you find it in environmental agencies, that people have really hard time in deciding anything if they don't have lots and lots and lots of data. They sort of want to be sure that nothing bad is gonna happen. Mm-hmm. We kind of understand, because that's their responsibility, because they will approve some projects based on that or not, but it's evolving really slowly towards something that, okay, you can decide things based on what you already know and based on, simple logic, because sometimes it's really easy to say that A is better than B. Mm-hmm. Sort of thing. Mm-hmm. And my question finally is, did you face any kind of challenge in terms of people getting suspicious about the quality of the results in the cases you don't have much data at all?
Yeah, I mean, it's always true that there are people and skeptics, thankfully, who say, we need more data, we need better data to help us understand, the potential benefits of a design or the costs to a particular design. And phishing data is often one of those sorts of data sets that is hard to come by, or if it exists, it's not public. And so we can't necessarily use it in a meaningful way. But with those stakeholder surveys, oftentimes if people have seen how we've collected it and provide good metadata for how that information was derived, we get more and more acceptance. One of the nice things about SeaSketch is that it does have these forums, and oftentimes the projects have these open forums where people are welcome to go and criticize the process and criticize the data. And so just by simply having a platform that allows people to express their concerns and then allows people to respond to those concerns by saying, look, we're working with the best available data. maybe, you know, these plans aren't the best possible designs, but they're the best we can come up with for now. And, you know, we have a mandate, we have a law that says we have to do this comprehensive planning. So we're going to go ahead and move forward with the plan for now. But an important part of marine spatial planning, which I didn't mention earlier, is that it is in itself an iterative process. So you create the plans, you monitor their effectiveness over, say, a 5-year period, reevaluate whether the zones are working. If you have better data at that time, maybe you shift the boundaries of the zones, and then you adapt. It's an adaptive process. You change the plans in accordance with, you know, how they're working and whether or not new information has been revealed. So yes, I mean, we always get criticism and for the data that we have or the data that we don't have. And the standard line is we're going to use the best readily available data, collect more data to have better decisions over time. Maybe it's over the course of the planning process, we'll collect new data. And then, of course, we'll collect new data and monitor the effectiveness of these zones over time to then adapt them in response to better information. Oh, you're still muted.
Oh, yeah. One specific question is about those forms. Once you have a license, you can make those forms yourself, or we depend on you to set them first.
Yeah. So when somebody gets a license for SeaSketch, we make them an administrator, and so the administrator can go in and create. They can pretty much do everything that you saw except for create those analytics. So an administrator can add data layers. Administrator can create new sketch classes. These are the zones, for example, that you draw, and the attributes you apply to those zones. And then you can create forums and surveys, any number of them. You can create as many as you want. So that's very easy to do. It doesn't require any level of expertise. If you can use a web browser, you can create all these different things. You can create forums and surveys and add new data, blah, blah, blah. The only thing you can't do on your own without my intervention is creating those analytics and reports. So I see there's another question in the chat that says, is it usually necessary to customize the SeaSketch to apply in a certain area? Is the customization usually done by SeaSketch staff, or can it be done by the user? So yeah, I think I just addressed that. That is, the end user can't configure SeaSketch, but the project owner can. So if Tomas wanted to create a project, I'd just poke a button, create the project, make him an administrator, and send him an email, and he could do all that configuration on his own.
Okay, another question is about the projects that you already run. You have like planning projects and educational projects. What exactly are the educational projects, and how does that work? Okay.
So we provide free licenses for educational projects, and they can be for teaching purposes. So for example, if you're teaching marine spatial planning, I can create a project for you and send you a link, and you're able to use it on your own. If you're a student and you want to do surveys, for example, you want to work with some fishermen and ask them to identify areas that they're important to them, or whatever you want, ask spatial questions, that's an example of a free educational license. If you're doing research as a professional researcher, and just want to do some collaborative discussions with your colleagues around spatial information, maybe planning to do research, all of those things are things that would happen within or in association with an educational institution, and those are all free. What we can't provide you for free is that analytical work. So if you wanted to do some sort of analysis in SeaSketch, unfortunately, we can't provide that for you because it takes time, and my staff need to be paid for that. So, but in the next version, the free and open source version, then you will be able to create those analytics on your own for free without any intervention from my lab. So the only time that we charge for SeaSketch, when we charge the license fee, is when it's actually being used for an honest to goodness planning initiative where there's a government and probably an NGO and a foundation involved, and they are going to use SeaSketch to its maximum extent by creating those analytics and getting help from me to do facilitation and my staff to do various kinds of GIS work. So that's when we charge a fee, and we create a contract to provide that work. So if you're interested in a free educational version of SeaSketch, just email me. I put my SeaSketch. I would request, if it's appropriate, to be a co-author, or if not, just a mention, because that certainly helps me.
Well, let's see if anybody still have any questions here. Mais ninguém, gente? Well, if not, I will thank you again for your time, Will.
You're quite welcome.
Appreciate it.
Thanks for the invitation. It's been fun.
And I hope to invite you to come, in person someday, maybe.
Yeah, I'm in as soon as we can. Yeah,
okay.
Just wait for the pandemic to be over.
Obrigado, pessoal, também, que depois eu vou descobrir quem é, que está aí do outro lado. E se tiverem alguma outra questão depois, mais tarde, eu acho que tem os dados do Will aí de contato. E acho que é isso. Thanks again.
You bet.
Have a wonderful Friday.
Obrigado.
Inside your house.
Exactly. You too.
And see you next time.
Yeah.